Day 15 of 60 in our DSA in JavaScript challenge. And today we kill off by one bugs forever. Quick demo. I've got a sorted array with 1 million numbers. Running index of to find the last element in node, 15 milliseconds, because it scans every single item. Binary search, under 1 millisecond. Same answer, but it makes around 20 comparisons instead of a million. That's O log n versus O n. And once you internalize it, you'll reach for it in every interview. Let's build it. Here's the classic exact match version. We track 2 pointers, left at 0 and right at array length -1. While left is less than or equal to right, we compute the middle and check 3 cases. If the middle value equals our target, return that index. If it's too small, move left to mid +1. If it's too big, move right to mid -1. The whole game is shrinking a window without ever stepping over the answer. Picture it on a whiteboard. Every loop throws away half the array. Now the line everyone writes wrong, the mid calculation. Don't write left plus right divided by 2. In languages with fixed integers, adding 2 huge indices overflows. JavaScript numbers are doubles so you won't crash, but the habit matters in interviews where you're judged on rigor. The bulletproof version is math.floor of left plus right minus left divided by 2. You compute the offset from left, then add it. No overflow, ever. Bonus, the bit shift trick, left plus the gap shifted right by 1, divides by 2 in one operation. Exact match is the easy case. Real interviews want boundaries. Take first bad version. Versions are good, then bad, and you want the first bad one. This is the leftmost variant. Use a half-open interval, left at 0, right at length. While left is less than right, not less than or equal. If mid is bad, set right to mid, keeping it as a candidate. If mid is good, set left to mid +1. When the loop ends, left points at the first bad version. Notice we never wrote -1. The window collapses onto the answer. Flip the bias, and you get the rightmost variant, the last position matching your target. Same skeleton, but when mid equals the target, you move left to mid +1 to keep searching right, and you remember the index. This shows up in find the last occurrence or counting duplicates in a sorted array. The mental model, leftmost biases the window toward smaller indices, rightmost biases toward larger. Pick your bias, stay consistent, and the off by ones disappear because you trust your invariant instead of guessing. Here's the trick that separates senior candidates. Binary search doesn't need an array at all. Take minimum days to make M bouquets. Brute force tries every day from 1 to the max. That's O, n times M, and painful. Instead, binary search the answer space. The days range from 1 to the maximum bloom day. Write a feasibility check. Can I make M bouquets in this many days? That check is monotonic. If day 10 works, day 11 works too. So you binary search for the smallest day that passes. You just collapsed a hard problem into 2 simple ones. So which variant do you reach for? Listen for keywords in the prompt. Does it exist or find the index, exact match? First, smallest, minimum that satisfies, or insertion position, leftmost boundary, return left instead of -1. Last or largest valid, rightmost boundary. And minimum or maximum value such that some condition holds. That's binary search on the answer with a feasibility function. Map the words to the variant before you write a single line, and you'll never freeze at the whiteboard. 2 edge cases that catch people. First, your loop must always shrink the window. If neither pointer moves, you spin forever. With less than or equal, you write mid +1 and mid -1. With the half open less than, you write mid and mid +1. Second, the empty array. Left starts at 0, the condition fails immediately, and you safely return not found. Test those 2 cases out loud in the interview. It signals you actually understand termination. Day 15 done. The takeaway, binary search isn't memorizing a loop, it's defining a search space, committing to an invariant, and shrinking the window without losing the answer. Master the 3 variants plus answer space search, and you've covered the majority of interview binary search questions. Subscribe for day 16, where we tackle the two-pointer technique.